Well, thank you very much for the welcome, the after lunch slot. And so it's lovely to be here. Thank you for the introduction. So yes, my name is Joanna Huddleston, and I job share with Helen McComb. We've been doing that for about 7 years. So some of you may have met her. She's the Scottish one, but to all intents and purposes, we are the same person to the extent that I'm actually wearing her name badge today. So I wanted to talk to you about some of the work I do on hydrogen innovation at the Department of Energy Security and Net Zero, but I'm also going to talk a little bit about hydrogen policy in the department overall, and also how we think about innovation from the department to kind of set the context of that. But then I'm going to go on and talk about some of the projects I'm involved with at the moment, some of our larger demonstration projects, because we're at a really exciting time where the results are coming through. So that's what I'm going to do. I will say, somewhat contrary to your introduction, I am not here to tell you exciting things about new steps in government policy or new funding opportunities. That's not where we are in the cycle, but I hope that I can give you a good picture of where we are right now, and I'm delighted to hear your ideas and suggestions for what we might do in the future, even if I can't say anything massively interesting in return. So that's my intro. So I'm going to talk about something called the Net Zero Innovation Portfolio, which is the main vehicle that my directorate has been using to deliver. Actually, I think we've skipped a couple of slides, actually. Yeah, sorry. I'll go back to the beginning. Innovation is essential for net zero by 2050. I think you all know this. You will have seen a version of this slide before. The UK has made some great progress on emissions reduction, but if you look at, so for example, information from the IEA, they estimate that 30% of the remaining technologies reductions we need to get to net zero are from technologies that aren't yet commercially available. So innovation is necessary over the course of the next decade, and we need to do that now. And I think, so what we've been doing over the past few years is delivering something called the Net Zero Innovation Portfolio. So this is £1 billion that aims to accelerate the commercialisation of innovative low carbon technologies. And we've got 10 technology themes, which are listed on the slide here. I've been heading up the hydrogen theme with Helen. So we think of ourselves as operating a joined up approach to commercialising innovations. So alongside the technologies that we support, we also have acceleration support services. So we provide business support to SMEs in order to help them commercialise their technologies. And we've also supported something called the Clean Growth Fund, which the government put £20 million cornerstone investment into this commercially run fund to help support that pathway for innovations to commercialise through to deployments. We've supported innovation and deliver benefits across the country, and it's a really diverse range of companies. 74% of our lead organisations are SMEs, and 85% of our projects are located outside of London. So I'm now going to switch gears a little bit and go to the why hydrogen. I think you all know this, but I think it's useful to think about it a bit in the context of the way we're thinking about it in government. So we're very much focused towards delivery of the clean energy, superpower and growth missions, and low carbon hydrogen will play an important role in both of those as a key enabler of low carbon and renewables based energy. So, it can be used as a fuel, it can be transported, it can be stored, it can provide flexible low carbon power generation and long duration energy storage. It also will play a role in decarbonising industry, and it's a leading option to decarbonise heavy transport, including shipping and aviation. So I'm not going to dwell on this, the kind of the policy side of this, because this is an innovation conference, but I wanted to talk a little bit about the most recent government statements on hydrogen, and particularly to commend to you the Hydrogen Strategy Update to Market, which was published in December 2024. There have been a series of these documents published roughly every 6 months, and they've talked about what's been going on in hydrogen. They have a section in them about R&I and what's been going on across the public sector. And I think they are a really good summary of where the government's at in hydrogen. So look out for these, because I appreciate this can sometimes feel like a lot of consultations, policy documents, some quite detailed stuff. The hydrogen strategy is the document that brings it all together. So I'm not going to read out everything on the slide, but just to pull out a couple of things that I thought might be interesting to this audience. So government has confirmed support for the hydrogen business model project. So this is revenue support for hydrogen production, and the first contracts have been issued. We're continuing to develop the low carbon hydrogen standard. There's a consultation on hydrogen for heating is coming in 2025. I say that because that's quite often a question we get asked in these scenarios. So the link's there, do check it out. This is a diagram that comes from a previous hydrogen strategy updated market, which I quite like, because it just shows the landscape of public sector hydrogen research and innovation. And it's complicated because hydrogen is a complicated and diverse sector, and that's okay. And that's why events like these are great, because they bring lots of people together from lots of different parts to talk. So this is probably a little bit out of date. It's from 2023. The UK, since then, I think the UKRI EPSRC-supported hydrogen hubs have I think they probably existed when this diagram was written, but they've certainly sort of become a bigger part of the landscape. But yeah, check this out if you want a kind of a summary of public sector hydrogen research and innovation. I think this is quite a nice one. So I'm going to go back to what we do in my directorate in Science and Innovation for Climate Change and Energy, so based in the Department for Energy Security and Net Zero. So we have this portfolio that is focused on commercialisation, innovations that we think have a route to commercialisation, that we think are going to make a difference to net zero in the near term. So so this diagram's got a little bit disjointed, so apologies for that. But I just wanted to show you here kind of how I think we estimate about 170 million of the 1 billion has supported hydrogen projects, and how that splits across the value chain. So the low carbon hydrogen supply 2 competition, which is this one here, kind of spans production and transmission and distribution. I'm going to give you a few examples from that one later, because that's the one that Helen and I have directly looked after. We've also got industrial fuel switching, and that's supported some end-use hydrogen projects. Hydrogen skills and standards, which is some more technical stuff to do hydrogen heating. Long-duration energy storage, which has had hydrogen projects within it. And H2BECCS hydrogen from biogenic feedstocks. And then at the bottom, we've got our end-to-end programs. And these have been so interesting and important. And if I'm honest, it's hard, because joining up the hydrogen value chain is hard in an emerging sector. And the one I'll talk a bit more is the Industrial and Hydrogen Accelerator, which is the one that Helen and I have looked after. But these are really interesting programs where people have joined together the whole chain, and there's some really interesting results that I'm looking forward to seeing from all of these. So this is what we've been doing, and I'm going to take you through a couple of the programs that Helen and I have been directly running. So starting with low carbon hydrogen supply 2. So this followed on from the low carbon hydrogen supply 1 competition, because hydrogen is still too expensive, and it still can't be produced efficiently enough to do everything that we all want it to do. So the way we designed this competition was that we wanted to be able to support projects that were ready to go and build a demonstration and kind of prove their technology at the kind of TRL 6 or 7 level. But we also wanted to support smaller companies, perhaps, that had really great ideas, but that perhaps weren't quite ready to apply to do a big demonstration at the kind of £10 million mark. So we had 2 streams. Stream 2 went straight to demo. Stream 1, we had feasibility studies, and then we down selected from those to support some demos. So all of the feasibility reports are available on gov.uk. I've included a link. There's some really interesting studies in there, like LOHC, lined rock caverns, kind of lots of some nuclear coupled ones. There's some really interesting stuff. As where we are at the moment is that my time is really focused on the big demos, which are coming to an end at the moment, because our funding runs up to 2025. So we had in the straight to demos, we had ITM's project Gigatest, we had GemServe's ammonia cracking project in Tilsley Park, we had H2Go solid hydrogen at low pressures, Vattenfall's electrolysis offshore, which I'll talk a bit more about later, and ERM Dolphin, which is saltwater electrolysis, which I will also talk a little bit more about later. And then in the projects where they did the feasibility report first, and then we down selected, We have University of Manchester, which is chemical looping reforming, and this is our only kind of CCUS, well, this is our only kind of blue hydrogen project. I'm going to talk a bit more about that later. We've got Tektronix hydrogen plasmolysis, which I went to visit in Swindon last week and saw it turned on and generating hydrogen, which is fantastic. We have STFC's ammonia synthesis in Harwell, Immaterials monolithic MOFs for hydrogen storage, and Actuation Labs leak-free dragonfly valves for hydrogen. I'm not going to talk about actuation in detail, but this was something we did a bit differently with hydrogen supply too, is that we wanted to enable projects that were around distribution and use and kind of supply of hydrogen and kind of that wider system, not just hydrogen production, which the first competition really focused on. And I think that's been a really interesting project. And yeah, and what's been lovely about this is Actuation Lab and STFC are collaborating, and Actuation Lab are going to test some of their valves on the STFC plant, which obviously as a funder makes me really happy. So just to talk a little bit more about some of the results. So the ERM Dolphin commercial scale demonstrator, so they have put an electrolyser and desalination equipment out to sea, and they have produced hydrogen offshore in Milford Haven. And so we've shown that works in those conditions, that all of the technology is performing, and it's been really interesting, and hopefully that final report will be available relatively soon. No technical barriers were identified, but there are some other barriers or kind of issues that come out, and I think that's what can be really interesting about these larger scale innovation projects, is that they really start to show you how the supply chain is operating and kind of the pathway to deployment in a way that obviously smaller projects don't do as well. So there have been supply chain challenges to navigate, and ERM have done this very successfully. Electrolyzers are available, lead times are high. I mean, that's been a recurring problem with all of our projects. Electrolyzers and compressor lead times are an issue, and it's something that projects really need to plan for. I think the other thing that has been really interesting from this project and the Vattenfall one is around permitting and consenting, and how we get a framework that works for this type of project. So both of these projects have been really helpful in contributing to some changing regulations on offshore pipes, which before a few years ago we didn't have a consenting regime that would allow you to put an offshore hydrogen pipe. We now have a regulator and a consenting regime that can start to come into place, and that these innovation projects have been able to feed into that, which has been really interesting. The next project I wanted to mention was Vattenfall's wind powers project. So this was they wanted to put an electrolyser on a wind turbine and demonstrate hydrogen production and pipe it offshore. And the final report from this project has been published, and there's a link in the slides, and I would commend it to you. It's a really nice report. As it turned out, the project concluded at the design stage because rising costs and also difficulties in connecting up supply and demand, because there wasn't at that point somebody that could take the hydrogen in the port. And I'm not going to shy away from the fact that this is a problem with innovation projects, that you have to, if you're making large-scale hydrogen, you have to think about where it's going and what you're going to do with it. And I'll touch on that a little bit more when I talk about the Industrial Hydrogen Accelerator. But still a fantastic project that has brought a lot of learning about how you do these kind of projects, what things you need to consider, safety, consenting, technical, and I would commend the final report to you. Okay, yeah, so I think this is largely things I've already said, and there's a diagram of what the FEED study covers, and PEM electrolysis is well suited to offshore wind, and I think that won't be a surprise to this audience. So the final project I'm going to cover in low carbon hydrogen supply is this one we're working on with Manchester. So this is one of our projects that started later, having done the feasibility study. So they've been making hydrogen using a looping system, which because it intrinsically captures the carbon as part of it, it's much more efficient. So it's a modular design, and the consortia think there's a lot of potential uses for this, including steel production, syngas production, lots of different things. And they've produced the plant, and the testing is going to begin shortly. And they've got a great website, and I'm looking forward to the final report for this being available later in the year. But I think it's a really interesting one. Again, there's always supply chain issues and challenges, and which we've worked through with the project, but they're at a really exciting phase where they're starting to see that the testing results will come through soon. So finally, I just wanted to talk about the Industrial Hydrogen Accelerator, which was a program we set up to think about this challenge of how do you integrate the whole hydrogen value chain? How do you go from generation to storage to use in an industrial application? And so we wanted to look at it as a system, and it's something that the Green Distilleries program was already doing, but obviously clues in the name, just for distilleries. We wanted it to be an option more widely, and I think it's been a really interesting program because we've got some really interesting projects, but it does, at this point in time, it can be hard to marry up supply and demand and kind of get that all working together. I think that projects have appreciated having the feasibilities money to kind of work some of that through, and that definitely led us to better projects in the end. So the one I wanted to talk to you about today was a project we've been doing with E.ON, who we're also working with Chesterfield, Glass Futures, Sheffield Forge Masters, Liberty and Forge Solutions, and this one has recently concluded. We haven't published the final report yet, but they've had kind of end of project events. So they have done a feed study integrating hydrogen production with the existing Blackburn biomass power plant and surrounding secondary steel industries, and they seem to have got a lot of traction in the local area, and it's been a really interesting project to see how all of those partners are being brought together to work on solving this challenge with hydrogen. So I think that is everything I've got to say to you. So it's great to be here, and I'm very happy to take any questions if we've got time.
Yeah, we've got 2 rolling mics here. So if you have any questions, just raise your hand and we'll give you the mic.
You touched on the maritime industry. I was just wondering, do you have much involvement with the maritime industry, or is it predominantly shoreside, and are you open to discussions on that?
So for me and the programs I've run, it's predominantly shoreside. We obviously join up with DFT, and we have kind of various mechanisms that we look at to make sure that our programs are kind of complementary, and policy colleagues are also doing the same. But yeah, it's DESNZ is it is that kind of DESNZ and DFT thing on there.
Yeah. Okay. Thank you.
Hi, it's Sean Williams, Teesside University. You've touched in briefly there about the supply and demand equation. Interested how government are trying to solve the chicken and egg problem.
So I'm not a policy person, I'm an innovation person, but I think the comment that I'm going to make is that our hydrogen business models require you to have an off-taker in order for the contract to be signed, which means that from the get-go of those projects, you've got to have thought about that, how that all works. And I think that's quite an interesting and powerful model. I think that as we are in an emerging industry, I think a lot of people thinking about how you distribute and store and supply hydrogen more efficiently. I've been doing some work with the Carbon Trust in a program called the Clean Hydrogen Innovation Program, which brings together industry to kind of look at common problems, and they've just done a study looking at the economics and carbon emissions of different distribution mechanisms and kind of what the trade-offs are there. But I think it's something we're going to continue to grapple with.
Just to follow up then, do you think that financial incentives from a government perspective would help generate that supply and demand?
I don't think I've got anything more to say than I already have.
Okay. Any other question?
Ian Hibbett from BOC again. I noticed on your slide, Pat, you mentioned the HAR1 round. When do you think those projects will actually start?
First contracts have been signed. Sorry, it's not my area, so it's not for me to give you a date, I'm afraid. That's a bit of a dodge, but yeah, but it is exciting that those first contracts have been signed now, and things can get going.
Considering the projects you've awarded funding to, how do you see them as successful, in the sense of how do you measure their success? And from the ones that have been awarded funding, why and how, in the sense of, is it a case of, as you say, off-takers, but also a case of the collaboration piece, or is it in the case of taking advantage of niche areas? Is that, how do you score and categorize the projects in terms of why and how they get funding?
Okay, so I feel like it's kind of two questions there. Is how one is sort of how do we evaluate projects and how do we look at them once they've completed, and the second one is how do we assess them in the first place? And we publish ITTs which set out our assessment criteria. We look at a range of factors which we're upfront about. For example, in the Industrial Hydrogen Accelerator, yes, we looked at that whole value chain, and we looked at the kind of the credibility of that. In the Hydrogen Supply 2 competition, we would be looking at what projects we're predicting about cost and efficiency of the hydrogen production, and what evidence that they had to support that. So that's the kind of things we do, but we're very transparent about that, and we explain how it's weighted. And all of that. I think on how do you judge a project's success is a really interesting one. I think innovation, we're comfortable with the fact that innovation projects can, quotes, fail, as in, they won't necessarily do what you set out to do at the beginning. We manage our projects through change control, and we work really closely with them to kind of get the best possible outcomes and the benefits from taxpayers' money. One of the things we do in the Net Zero Innovation portfolio, which I think is great, is that we do a lot of follow-up with our projects. So we have key performance indicators, and we go back to our projects throughout there while we're funding them, but also for up to 3 years afterwards, saying, what are you doing? What TRL are you at now? How much follow-on funding have you got? So we've actually got really good data from Net Zero Innovation portfolio, but also the portfolio we funded before that, showing that progression and sort of showing the impact of our funding. And I think that's something that we're really proud of in our directorate. And there's so we published a progress report, I think it was a year or so now ago, Net Zero Innovation Portfolio Progress Report, and that has some of that in it.
Thank you very much, Joanna. I'm Frank Ashton from Chesterfield Cylinders, part of the consortium you were looking at just on the slide there. So thank you very much for your support. It's been a really interesting process to be part of, and happy to talk to anyone who wants to find out about what it's like to be on this side of the funding process. I guess my question, Joanna, would be, do you have anything you can share with us about the next tranche of funding that might come through? And I'm sure there's lots of question marks about that at the second, but what can you share, and what might be the timetable if possible? Thank you.
I'm really sorry, because we're in the middle of a spending review. I think I'm a good civil servant. I'm preparing for a range of outcomes. I would be delighted to hear your suggestions and ideas. But there's nothing I can say about a timetable at this moment.
Okay, well, thank you very much. We'll call the session to a close. Thank you very much, Joanne, and can you